Hello everyone, boiler and the ancillaries. The chapter will cover ancillaries that are associated with the boiler and the mountings on the boiler for today. Ships have evolved over the period of time, and so have boilers. Earlier, turbine powered ships had high requirement of steam, and so the size of the boilers used to be huge. Now, IC engines, motor ships as we call them, they require much less steam compared to the turbine ships. Hence, the size of boilers also have reduced over a period of time. If you look at broadly, today you will only talk about boilers as water tube boilers or smoke tube boilers. But there are a varied range of boilers which we will talk about during this course. Talking about boiler and ancillaries, we will be covering the boiler mountings, the most prominent one being the safety valve, which we will go in depth. Coming next would be water level indicators. We will be covering both direct level indicators and remote water level indicators. Other minor mountings would be soot blowers and feed valves. Safety valve. Why do we have a safety valve? Purpose is simple. It releases the excess pressure beyond the design working pressure of the boiler. We need to know some basics regarding the size of a safety valve for a particular boiler. To know that, there is a basic formula of CAP equals 9.81 into H into E. The description of each parameter is described on the screen that you see.
H is the total heating surface in meter square. E is the evaporative rate in kilogram of steam per meter square of heating surface per hour. And P is the working pressure of safety valves in meganewton per meter square. A is the aggregate area through the seating of the valves in millimeter square. And C is the coefficient of discharge depending on the type of valve used.
One should know that no safety valve should have a valve which is lesser than 38 mm. Considering the boiler to be operating at fixed conditions of constant discharge and constant pressure, the equation can be deduced to d square c equal to constant, d being the diameter of the valve and c being the discharge coefficient depending on the type of valve being used. So one can evidently see that if c is increased, d needs to be decreased. Now if d is decreased, the valve lift has to be increased to compensate for the discharge of steam so as to avoid accumulation of pressure. On the screen, you will find typical valve lifts, which are basically an approximation for various discharge coefficients of valves. Among the various types of safety valves, we will be learning in detail about three types: improved high lift safety valve, full lift safety valve, and full bow safety valve. Improved high lift safety valve is the one which we predominantly see on board the ships. This valve itself has undergone an evolution from being a wind valve to becoming a high lift wind waste steam piston valve to a improved high lift safety valve with a floating ring. What you see on the wall is a cross section of an improved high lift safety valve.
The prominent components that we need to note with this cross section of an improved high lift safety valve are the valve spindle, the valve spring, the spring covers. The bottom spring cover also acts as the waste steam piston, the compression screw, and the compression ring. And if you notice the spindle has a neck. The neck is pushed down by the bottom spring cover. Okay, and the entire valve spindle is connected to an easing gear, which means the easing gear can be used to lift the spindle slightly above to release the pressure as and when needed. If we take a closer look at the valve lid and the bottom spring cover, we can see that the improved design, the wingless valve, improves the steam flow and removes any risk of seizure. Additional to that, the specially shaped seat reflects the steam towards the lip on the valve and thus increases the valve lift. The other device which increases the valve lift is the bottom spring cover, which acts as the waste steam piston. The steam pressure also keeps the cylinder in place while the piston moves. Additionally, by having a floating cylinder, seizure is also reduced. The features of this improved high lift safety valves are: it is wingless, thus avoiding any risk of seizure. Valve lid and valve seat so designed so as to enhance valve lift considerably. And lower spring carrier compresses spring further by waste steam pressure. Full lift safety valves are used in boilers whose working pressure go up to a range of about 63 bar. Full lift safety valve does not incorporate a waste steam piston. Instead, the valve itself, operating inside the guide, acts as a piston in a cylinder. Other details like spring, compression nut, easing gear, and valve chest, etc. are the same as improved high lift safety valve. Now here, when the valve has lifted a small amount, the escaping steam pressure can then act upon the full area of the valve. This increases the lift until the lower edge of the valve just enters the guide. At this point, the reaction pressure generated by the escaping steam with the guide causes the valve to lift further until it is fully open. When the valve is fully open, the escape area is said to be equal to the area of supply through the seating. Full bore safety valve. This kind of safety valve is used on boilers, especially water tube boilers, whose working pressure is in excess of 21 bar. When the boiler actually reaches the desired blow-off pressure, the relay valve lifts. As it lifts, it blanks off a series of ports which are leading to the atmosphere otherwise. Steam is then admitted via the connecting pipe into the cylinder of the main valve, and since the area of this piston is about twice that of the valve opens against the boiler pressure. When the boiler pressure falls, the relay valve closes, uncovering as it does the ports above it. This communicates with the cylinder of the main valve with the atmospheric and the boiler pressure, then causing the main valve to close rapidly. These kind of valves are applicable and positively good only with high pressure boilers because the closing time is pretty quick. In doing so, enormous amount of steam is saved. The spring-loaded main valve, as you can see from the diagram, keeps the valve shut positively when the boiler is cold. One of the important tests that a safety valve undergoes is accumulation pressure test. This test of a safety valve is essential during commissioning of a safety valve on a boiler to ensure that the safety valve is of correct capacity for that particular boiler. The test is carried out for a period of about 7 to 15 minutes. All feed to the boiler is shut off during this accumulation test. After ensuring there is enough water in the boiler, the burner cutoff pressure is increased or totally cut off as deemed fit at the situation. The boiler firing rate is then increased to a maximum firing rate. The test is carried out to maximum of 10% above the normal working pressure of the boiler at any given time during the planned duration, and it has to be ensured that this pressure is not exceeded. During the accumulation pressure test, the safety valve is still set at a lifting pressure of 3% above the working pressure of the boiler, and so it keeps lifting during the test. Endurance of the valve is thus tested during the planned duration or until the water level is safely sufficient. Next comes the procedure for setting a safety valve. Ensure that the drain lines are clear. Ensure that the pressure gauge is new or lately calibrated one. It is always better to use 2 pressure gauges for accurate setting. Shut all inlet-outlet valves after water level is found stable. If necessary, Feed inlet valve needs to be kept open to maintain the water level. Gag one safety valve so that only one is able to lift. Change over burner to manual firing mode to avoid cutoff at high steam pressure. Raise the steam pressure of boiler gradually. If the valve does not lift at the desired setting, crack open steam stop valve to release pressure below desired pressure of lift. Adjust the spring tension, taking due precaution if in case there is an accidental lift during adjustment. The above three steps to be carried out till the safety valve lifts at desired or the correct pressure. Shut off burner when the valve lifts. Measure the distance between the compression ring and the valve body. Change over the gag and similarly set the other valve for the desired pressure. After both the safety valves are set, release the boiler pressure and fit spacer rings beneath the compression ring as per measured value taken earlier. Replace easing gear and lock top covers to prevent further spring adjustment. Check that all gags are removed. If the surveyor is on board, safety valve to be relifted and working condition to be shown to him. Check that high steam pressure trip is operational and then record the valves of safety valve opening pressure in the engine room logbook and the spacer ring size and obtain a signed sealed certificate from the class surveyor for the vessel's record. Gauge glass is an important mounting on the boiler. It is the direct visual indication of the boiler water level. Conventional water level gauges consist of the gauge body with isolation cocks or valves towards the steam end and the water end of the flanges, and a drain cock at the bottom. The reflex gauge glass is attached to the body by a sealing gasket on the gauge body side and a cushion gasket on the cover flange side. U-bolts hold the body, glass and cover flange together. Since the gauge glass is an important mounting which shows a visual indication of the water level, it is necessary to keep it reliable at all times. One of the routines is blowing down of the gauge glass. To do so, first close steam and water cocks, then open the drain. After the gauge glass water is drained, nothing should now come out of the gauge if the steam and water cocks are not leaking. Now open and close water cock to check that the water cock connection to the boiler is clear. Open and close steam cock to check that the steam cock connection to the boiler is clear. Now close the drain. Open the water cock. Water should now gradually rise up to the top of the gauge glass. Open the steam cock and the water in the glass should fall to the level of the water in the boiler.
This procedure needs to be done on a periodic basis to ensure that the passages from the boiler to the gauge glass is clear at all times. It is also done to maintain the gauge glass itself.
Among other boiler mountings, we have soot blower. Soot deposits on heating surfaces needs to be periodically cleaned to maintain the design efficiency of the boiler. Hence, the requirement of a soot blower. On screen, we have the basic pictographic model of a soot blower. Varied soot blower contraptions are being used by leading boiler manufacturers to effectively remove accumulated soot deposits. The feed check valve is an important mounting on the boiler which is between the feed water pump discharge and the high pressure water inside the boiler. A typical valve and its cross section as shown is ideally a non-return valve assembly. The design varies basis the working pressure against which it serves.
That completes the important boiler mountings section. Fuel and air blow system. Almost all boiler burners are designed to handle fuel whose viscosity range between 2 CST and 17 CST. And also it is designed to support the pumping systems of fuel which are associated for the boiler burning. For complete and efficient combustion to happen, the right quantities of fuel and air needs to be mixed. About 14 times as much air is required for an efficient combustion to happen. The air and fuel has to be intimately mixed to achieve complete combustion. And sometimes a small percentage of excess air is introduced to ensure that the combustion is complete. If there is insufficiency of air, it may result in black smoke and also unburned fuel passing off. Now, the flow of air through a boiler furnace is known as draft. Marine boilers are arranged for forced draft. FD fans force the air through the furnace. Several arrangements of forced draft are possible. The usual forced draft arrangement is a large fan which supplies air along a ducting to the furnace front. The furnace front has an enclosed box arrangement known as an air register, which can control the supply of air.
Thus, marine boilers can operate on both heavy fuel oil and marine diesel oil. The fuel service systems on board are so designed to conveniently change over either due to regulatory requirement or for other reasons such as shutting down boiler for maintenance. With respect to burner type, most commonly seen burner types on board are rotary cup burner and pressure jet type of burner. Though we talk of boilers as water tube boilers and smoke tube boilers in general classification, various types of boilers exist based on the purpose of application with respect to steam demand and the nature of steam demand. Most prominent types are Cochrane boiler, Scotch boiler, Babcock and Wilcox boiler, external superheater D-type boiler. Cochrane boiler is a vertical drum axis, natural circulation, natural draft, low pressure, multi-tubular fire tube boiler with internally fired furnace. It is the modified form of a simple vertical boiler. In this boiler, the fire tubes are placed horizontally. The efficiency of this boiler is much better than a simple vertical boiler. Composite Cochrane boiler is an enhancement to utilize waste heat from the main propulsion system to increase efficiency of the propulsion plant, thereby reducing fuel consumption of essential steam services while out at sea. The Scotch marine boiler is a fire tube boiler. Hot flue gases pass through tubes set within a tank of water. The general layout is that of a squat horizontal cylinder. One or more large cylindrical furnaces are in the lower part of the boiler shell. Above this is a large number of small diameter fire tubes. Gases and smoke from the furnace pass to the back of the boiler, then return to the small tubes and up and out of the chimney. Babcock and Wilcox boiler was invented by George Herman Babcock and Stephen Wilcox, hence the name. This is a horizontal drum axis, natural draft, natural circulation, multi-tubular, stationary high pressure, externally fired water tube boiler. This is used in steam power plants. ESD type boilers are huge high capacity boilers used for high production of steam to run turbines. Mostly these types of boilers are employed in steam power plants. Boiler feed water systems. In case of a closed feed system, the feed system completes the cycle between the boiler and turbine to enable the exhausted steam to return to the boiler as feed water. The boiler produces steam which is supplied to the turbine and finally exhausted as low energy steam to the condenser. After condensation to water, it is pumped back into the boiler with the feed pump. In motor ships, the hot well or the cascade tank is open to the atmosphere. Such a system is therefore referred to as open feed. In the feed system, the atmospheric condenser is the most prominent component which maintains the feed system in a loop, be it closed system or an open system. The condenser is nothing but a shell and tube heat exchanger which removes the latent heat from the exhaust steam so that it condenses and can be pumped back into the boiler. This condensing should be achieved with the minimum of undercooling, that is, reduction of condensate temperature below the steam temperature. This is achieved by seawater cooling by a two-pass flow in the tubes.
Most pure water pumped into boilers contain dissolved salts which come out of solution upon boiling. These salts then adhere to the heating surfaces as a scale and reduce the heat transfer. This can result in local overheating and the failure of the tubes. Other salts remain in solution and may produce acids which will attack the metal of the boiler. An excess of alkaline salts in a boiler, together with the effects of operating stresses, will produce a condition known as caustic cracking. This is actual cracking of the metal which may lead to serious failure. The presence of dissolved oxygen and carbon dioxide in the boiler feed can cause considerable corrosion of the boiler and feed systems. When boiler water is contaminated by suspended matter, which can be an excess of salts or oil, may lead to foaming. Foaming leads to carryover of water with the steam when it is leaving the boiler drum.
This gives us clear objectives of feed water treatment in boiler. Prevention of corrosion, scale formation in the boiler. Prevention of corrosion, scale formation in the feed and condensate systems. Precipitating all scale forming salts into the form of a non-adherent sludge. Control of sludge formation and prevention of carryover with steam. Various amounts of different metal salts are found in water. These include the chlorides, sulfates, and bicarbonates of calcium, magnesium, and to some extent sulfur. These dissolved salts in water make up for what is called as the hardness of the water. Calcium and magnesium salts are the main causes of hardness.
The bicarbonates of calcium and magnesium are decomposed by heat and come out of solution as scale-forming carbonates. The presence of alkaline salts is known as temporary hardness. The chlorides, sulfates and nitrates are not decomposed by boiling and are known as permanent hardness. Total hardness is the sum of temporary and permanent hardness and gives a measure of the scale-forming salts present in the boiler feed water.
Hence, the boiler water needs to be constantly tested and treated. For low pressure boilers, lime and soda treatment and caustic soda treatment is done. For high pressure boilers, phosphate treatment and caustic soda treatment is done. Other treatments include adding coagulants and deaeration of water. Here are the standard values of various parameters of feed water and boiler water. These parameters have to be maintained at all times. There are strict guidelines and directions always provided by the boiler manufacturers. As was mentioned earlier, boiler manufacturers provide the recommended chemical treatment too. On board the ships, the chemical supplier provides a detailed procedure along with a test kit to carry out the various tests to ascertain the values of all parameters. Most of the tests can be summarized to the following: salinity test, pH test, alkalinity test comprising of P alkalinity, M alkalinity and total alkalinity, chloride test, sulfide test, phosphate test, count of total dissolved solids, and the hydrazine test.